Okay, 4.2, we're going to talk about solving systems of equations through substitution. So, how do you use substitution to solve a system of linear equations? Once again, we talked about a system of equations in the last section. But just so we're all on the same page, when they say substitute, they're talking about replacing something with something else. And in math, they specifically mean something else that it's equal to. So, for example, if I had two expressions where I told you 3x plus 4 is equal to f of x, and a second expression where x equals 3, I can take 3 and plug it in for x, which we do all the time. We're going to do the same thing on these. We're just going to plug in more than just little tiny things. So like this first one here, I know that x equals y plus 6. So I'm going to substitute for x y plus 6. So I'm going to have a new equation where y plus 6 plus y equals 10. Put my y's together, I get 2y plus 6 equals 10. Minus 6, 2y equals 4. Divide by 2. I find that y equals 2. So that's great. That means, to go back to the last section, that I know on my graph that if I were to graph this, I'm going to use a gray line, that it would have to hit my graph somewhere on this line of y equals 2. How do I find out where? Well, I take my y value, my 2, and I'm going to plug it back in this little box. I put a box around that just so it's easy to remember. I'm going to plug a 2 in there. And it's going to tell me that x equals 2 plus 6. What is 2 plus 6? 8. Meaning, 1, 2, 3, 4, 5, 6, 7, 8. These lines, without graphing them, I know this isn't the lines, but I know that they're hitting right there. I couldn't even draw it, so I quit. So, that is my solution. It is 8, comma 2, because my x was 8, my y is 2. So we plug it back in to find the number. Now, a lot of times, I'm going to clear this, so if you need to pause me and look at that again, feel free. But I'm going to clear this so I can do the next one. That's not what I want to do, but that works out. A lot of times, we're going to deal with substitution that looks like this, where it says y equals this, and the y won't necessarily be alone. What you do in this situation, we do the same thing. I'm taking that y, I'm more or less erasing it, and where that y was, I am putting what it equaled. So in this case, y equals 2x minus 1. This means now that to start the problem, before adding my y's together or anything, I have to distribute. Because this 3 was multiplied to y, well, this now took the place of y, so it has to be multiplied by that. So I'm going to end up with 2x plus, that ends up being 6x minus 3 equals negative 7. Now we start doing our usual stuff, combine like terms. I get 8x minus 3 equals negative 7. Add 3, find out that 8x equals negative 4, divide by 8, x equals a negative 1/2. So I'm going to take that negative 1/2, and I'm going to put it right back in that box, just like we did before. So it becomes 2 times negative 1/2 minus 1, because once again, negative 1/2 is my x. So you could actually, probably the better way to do this so we don't get confused, is to take the negative 1/2. I'm putting it here. That's my x, because that's what I found was x. On the one before, I could have written my y first and then went and found my x. So now I'm looking for what my y value is. So I'm going to solve this. Half of 2 is 1. Half of 2 is 1, and the negative makes the negative 1. Minus 1 is negative 2. So once again, this would have to cross, if I were to graph them, at negative 1/2, comma negative 2. And this is why substitution is nice. It allows us to solve problems that are maybe fractions or decimals without having to try and guess on a graph. That's why we have substitution, and what we'll talk about next is elimination in the next section. So, let's read this word problem. On Saturday, the vacation resort offers a discount on water sports. To take a surfing lesson and go parasailing, it costs $130. That day, 25 people took surfing lessons. 25 people surfed, plus 30 people went parasailing, and they totaled $3,650. Then, we go back to the original statement. It said surfing plus parasailing was equal to 130. Now this one, it's kind of harder to substitute, but all it takes is one step to make it possible. If I subtract the p, I now have an equation where s equals something. So I can take this, plug it in for s, and start working. And I'm going to go to a new page. Well, I'm going to write the equation. That better yet. Let's do this. So I'm going to start working 25 times 130 minus p plus 30p equals 3,650. Now let's real quick, before I go any further, I should talk about what does S and P actually mean in this situation. Well, since this is how much you're getting charged, this is surfing price and this is parasailing price. Okay? So that we probably should define that first, so I apologize for skipping over that. So I distribute 25 times 130 is what? Let's see. 130 be divided by 4 multiplied by 100? Yeah. So 25 divided by 4 is 3250. Now, should just grab a calculator, shouldn't I? All right. Yeah, it'd be 1/4 of that times 100. So it would be 3250 times 100 would be 3,250. I was right when I was starting to write it, and then I chickened out. That's why it's important to have confidence in yourself. Sometimes I do, sometimes I don't. Start solving. That's going to make 5p. I'm going to subtract this over. That equals 400. Let's do a bright purple. Divided by 5, divided by 5. 400 divided by 5 means that my P price is 80. So it costs $80 for a parasailing lesson. If I plug that in there, 130 minus 80 means my surfing lesson is 50. So I have my answers. Now I should read the rest of the question. What is the discounted price of each activity? Okay, so we now know. Sometimes it's important to read the question because sometimes they'll only ask you one. And so if they only ask you one, try to only solve for the one. Like if they would have only asked me how to parasail, the parasail price, I could have stopped here without doing this part. If they would have asked me only surfing, I would have wanted to manipulate this equation to make it P equals 130 minus S, because that would have eliminated my P's and helped me solve the problem. But we can talk about that more in class. Now I put these last two on here because, just like in graphing, it is possible, put that in there, it is possible still to get no solution or infinite solutions. So you'll notice, I didn't need to put parentheses on this actually, there's nothing to multiply it by. You'll notice that the x's here will cancel each other. If the x's or the y's or whatever variable you're dealing with cancel each other, all you have to do is look at what's left and ask yourself this question. When is it true? So when does 5 equal negative 4? Never. So it is no solution. If, on the other hand, you take this, and that's a 5, that's a blinking cursor, ignore that line. And you can ask yourself, when does 5 equal 5? And it's always, that's an infinite amount of time, so it's an infinite solutions. So those are your two, that's how you can tell if it's no solution or infinite solution on substitution, because that is still a possibility. Okay, so those are all my answers. Those are all my work. If you need to rewatch it, always feel free to. If you have any questions, you can come see me or email me. Otherwise, you can have a good evening, and I will see you soon.